problem. Third problem is calculate the number of moles of H2SO4 present in 500 milliliter of 0.1 m H2SO4 solution. We have to find the number of moles of H2SO4 present in 500 ml of 0.1 m H2SO4 solution. Now let's try to solve this problem. What we know, molarity is equal to moles divided by volume of solution in liters. First important point which you have to keep in mind, that in this question they have given volume in milliliters, it's not in liters. So the first point is what? First point is you have to convert this volume in milliliter to liters. So in liters this converted as 0.5 liters. So number of moles, from this what we can say, that number of moles of solute will be what? That will be equal to molarity of solution into volume of solution in liters. So molarity is how much? 0.1 into volume of solution is how much? 0.5 liter. So moles will be how much? Just multiply it, you will get number of moles is equal to 0.05 moles. Now if we know the number of moles, we can also find the weight of H2SO4 which is present. Now how can you find weight of H2SO4? So we know one formula, that number of moles is equal to given mass upon molar mass. In the previous question only we have used this relation, that number of moles is equal to given mass. So that given mass has to be in what? That has to be in grams. So given mass upon molar mass. So mass will be what? Mass will be equal to moles into molar mass. We know moles of H2SO4 in this question is how much? 0.05, and molar mass of H2SO4 is how much? 98. So multiply these two, you will get what? You will get the mass of H2SO4 present. So they can ask the question, same question, in two different ways. They can ask to calculate the number of moles, or they can ask the mass of H2SO4 that will be present in the given solution. So these are different types of questions, or the very basic questions that can be asked from molarity. Now we can also try to solve different questions on the basis of molarity by a simple formula, which is that molarity is equal to what? It is equal to number of moles of solute divided by volume of solution in liters. Let's say for example, we are having first container is having 100 milliliter of 2m H2SO4 solution, and second container is having, let us suppose, 500 ml of 1m H2SO4 solution. And what we have done, we are mixing the components of these two in a third container. So the content of these two containers are dropped in the third container. So what we have to find? We have to find the final molarity of this solution. Means if I'm mixing two H2SO4 solution, what will be the molarity of the final solution? In this, first we have to assume one point, that volume is additive. We are assuming in this that volume is additive. If these two solutions are mixing, there is no change in the volume. So volume will be what? Sum of the volume of these two containers. Now what we know, that molarity, we have to find molarity. So molarity is what? It is moles of solute. It is moles of solute divided by volume of solution in liters. Now if I want to find the moles of H2SO4, in the third container, that will be equal to what? That will be equal to, it's very obvious that it will be equal to moles of H2SO4 in the first container plus moles of H2SO4 in the second container. This is our first container, this is our second container. So if I want to find the final number of moles of H2SO4 in the third container, that will be equal to moles of H2SO4 in the first plus moles of H2SO4 in the second. So next task is to find the moles of H2SO4 in the first container. And what we know, that number of moles is equal to molarity into volume of solution in liters. So molarity given is what? 2. And what will be volume of solution in liters? So that will be equal to 0.1. So moles of H2SO4 in the first container is 0.2. Similarly, we can find moles of H2SO4 in the second container, that is equal to molarity of H2SO4, that is 1, into volume of solution in liters, so that is 0.5. So moles of H2SO4 in the second container is 0.5. So total number of moles in the third container, that will be equal to 0.2 plus 0.5, that is 0.7 moles of H2SO4. And what will be final volume of solution? So we have seen that volume is additive, so 100 ml plus 500 ml, that will give you how much? That will give you 600 ml. So total volume of the solution in milliliter is 600, so in liter it will be what? It will be 0.6. So directly we can write that will be equal to what? 0.7 divided by 0.6, so which is equal to 7 by 6. So molarity of the resultant solution is 7 by 6. Is this point clear? So this was another concept, which is addition of two acids, addition of two same acids. So let us suppose I am having another type of question, that we are having a container in which 500 ml of 0.1 m H2SO4 solution is present, and in this what we are doing, we are adding 500 ml of H2. So what will be now the resultant molarity of the solution? What we know, that molarity is moles upon volume. If volume of solution is changing because of addition of water, so molarity will be what? Molarity will be affected by change in volume of the solution. And this H2O which we are adding in this question, this H2 will do what? It will just increase the total volume of the solution. Again we are assuming that volume is additive. Again we are assuming that volume is additive. So initially what we can say, that moles of H2SO4 when water is not added, that will be how much? That will be equal to 0.1, that is molarity, into volume, that is 0.5, so it is 0.05. Why we are calculating the number of moles? Because what we know, that molarity is equal to moles of solute upon volume of solution, moles of solute upon volume of solution in liters. Now when we are adding water, the amount of H2SO4 or the moles of H2SO4, that will not be changed. Means whatever number of moles of H2SO4 is present in the first condition, same number of moles of H2SO4 will be present in the second condition. So in the first condition, what is the moles of H2SO4? 0.05. So in the final condition, what we can say, that moles of H2SO4 will be how much? That will remain as it is, which is 0.05. Upon what will be total volume of the solution? So total volume will be what? 500 ml of solution was initially present. Now 500 ml of water is added. So total volume will become what? 1000 ml. And in liters, what we can write? It is equal to 1 liter. So molarity of this solution will be what? That will be equal to 0.05. Is this point clear? So whenever I am adding water, you can see that concentration is decreasing. Means whenever I am adding the concentration, whenever I am adding water, the concentration of solution will decrease. And this is known as what? This process only is known as dilution of a solution. Dilution means addition of water so that it can increase the volume, and if volume of solution is increased, the concentration of the solution that will be decreased.